This question asks, consider the reaction between 1-butene and ammonia. What is the conjugate acid? Is the conjugate acid a stronger or weaker acid than 1-butene? In which way does the equilibrium lie? So at its heart, this question is an acid-base question. We're just kind of using an alkyne and an amine as our kind of key acids and bases for the reaction. So lots of review in this question regarding kind of earlier topics that we've discussed. So first off, don't try to do this in your head. Anytime you have a wordy question like this, I always recommend draw the whole equilibrium out and think about it again before looking at the answer choices. So the question is kind of hinting that we need to draw the equilibrium out too by asking what's the conjugate acid? Where does the equilibrium lie? So it really wants us to draw the whole thing out. So let's go ahead and do that. So we have 1-butene. So this is a little bit tricky in that we have to think about what the starting material is. We're just giving its name, plus ammonia. Ammonia is NH3. So we know we have a terminal alkyne, and terminal alkynes can have acidic protons. So here's our two reagents. And then we have our equilibrium arrow, and we're going to draw in the products. So to do that, I'm going to use my mechanistic arrows to kind of think about what we're making here. So in this instance, the ammonia is acting as the base, and the alkyne is acting as the acid. So the product that we make is this negatively charged sp hybridized carbon and NH4 plus. Okay, so the nitrogen adds a hydrogen, and so it's going to have a formal charge. So which molecule is the conjugate acid and which is the conjugate base? So the acid becomes the conjugate base, and the base becomes the conjugate acid. So we've kind of got a lot of our questions answered here with just thinking about what is the equilibrium, what's the conjugate base, what's the conjugate acid. Now we kind of need to think about which way does the equilibrium lie. And to answer that question, we need to either use a qualitative method looking at our two bases, or use a quantitative method using our two acids. So the quantitative method is the one that will always work because things like pKa values are measured. And so we have our two acids on either side of the equilibrium. Alkynes are typically going to have a pKa around 25. Protonated nitrogen atoms, like the one we have in our conjugate acid, are fairly acidic and will have a pKa around 10-ish. So just by looking at the pKa values, we know which acid is stronger. So the stronger acid is going to be the one with the lower pKa. So stronger, strong acid, and this is the weak acid. And from here, we can then tell which way the equilibrium lies. The equilibrium always goes from strong acid and strong base to weak acid and weak base. So this tells us that the equilibrium would lie to the left. All right. We can kind of look at our answer choices now and kind of think about what our answers are. We can cross off E right away because the conjugate acid doesn't make any sense there. It hasn't changed. The base is still NH3. If we're thinking about the second question, it says, is the conjugate acid a stronger or weaker acid than 1-butene? So the conjugate acid is stronger. You can cross off the answers that say weaker. Okay, so the conjugate acid is a stronger acid than 1-butene. And which way does equilibrium lie? It lies to the left. Okay, so that one would be wrong. And so our only option for the answer is again answer choice C. What if you wanted to use the qualitative method to examine the two bases? This is kind of a key area to look out for because it can be a little bit tricky. One method to qualitatively compare the bases is to use Cario. And sometimes it works and sometimes it doesn't. So this is just kind of an example where it would work probably here, okay, but it's a little bit trickier in this instance to compare a negatively charged carbon with an sp hybridized carbon versus a neutral nitrogen. In general, charged species are stronger bases, and that's what we determined just based off of our other assessment using the quantitative method. But just a reminder, the qualitative method's not perfect, so sometimes there are exceptions. And so that's just a kind of key thing to keep in mind. pKa values will not lead you astray, and they'll always be accurate. So it's better to do quantitative if you can, but qualitative can usually work as long as you keep in mind certain exceptions.